If you've ever been in a meeting where 20 people are all trying to talk at once, you know how chaotic things can get. Nothing gets done because everyone is talking and no one is listening. Routers feel the same way. In an OSPF network, if you have 10 routers on the same Ethernet switch and they all tried to form full adjacencies with each other, they would spend all their time just sending hello and update packets. It would be a total traffic jam. To fix this, OSPF holds an election. They elect a DR, or designated router, and a BDR, the backup designated router. Think of the DR as the room moderator. Instead of everyone talking to everyone, all the other routers, the DR others, only form a full relationship with the DR and the BDR. If a router has an update, it tells the DR, and the DR tells everyone else. It keeps the chatter to a minimum and saves the router's brain power for actually moving data. But even with a DR, OSPF can still get overwhelmed if the network gets too huge. Remember, every router has to run that complex SPF math every time a link flaps. If you have 1,000 routers, the math becomes too much. This is where areas come in. We break the network into smaller zones. You have Area 0, which is the backbone. Every other area, Area 1, Area 50, whatever you want to call them, must connect to Area 0. The router that sits on the fence between two areas is called an ABR, or Area Border Router. The ABR is like a translator. It doesn't pass all the messy, detailed Type 1 LSAs from Area 1 into Area 0. Instead, it summarizes them. It tells the backbone, hey, if you need to reach any of the networks in Area 1, just send the data to me. By keeping the details local to the area, we keep the routers happy. A link failure in California doesn't force a router in New York to rerun its math. It makes OSPF scalable, organized, and incredibly stable. So, when you're designing your CCNA labs, always start with Area 0. And remember, the key to a big network isn't more talk, it's better organization.